Hi students, welcome back to my channel Chemistry with Sarina ma'am. Today I have come up with one more interesting topic, that is from thermochemistry. Actually, thermochemistry you will study under thermodynamics only. Now we'll discuss a few topics under the thermochemistry. Many students have confusion that how to solve the problems based on this heat of reaction and standard heat of reaction, heat of formation, enthalpy of formation and enthalpy of combustion and enthalpy of atomization, like that. These topics are important according to your examination point of view. Now one by one we'll discuss how to solve here. First we'll discuss what is the heat of reaction is. Then after that we'll solve some previous year JEE questions. Okay, so that this topic will be more clear to you. Okay, now let's get into the topic here, that is heat of reaction. Heat of reaction means here, for example, let us consider any chemical reaction. Let us take A plus B gives rise to C plus D. Means here these are the reactants and these are the products. Okay, so during this chemical reaction, means here while the reactants are converted to products, during this chemical reaction, the heat change. What is that? Heat change. That heat change is nothing but heat of this particular reaction or any particular reaction. Heat change means many reactions may take place by the evolution of heat or by the absorption of heat. If heat is released in any chemical reaction, we call that as exothermic reaction. Exothermic. Exo means here given out and thermic means heat. Heat given out. Endo means absorption. Endothermic. If any reaction takes place by the absorption of heat, we call it as by the absorption of heat means if you give some amount of heat to these reactants, then only that will be converted into products. So here those type of reactions we call as endothermic. So here if in the heat change, whether that is an heat evolution or absorption, whatever the heat change is there, that is during any chemical reaction, that is called as heat of reaction. It is represented by delta HR. Heat content, change in the heat content. Delta means change. Change in the heat content of any particular reaction. Delta HR. Okay, this is heat of reaction. Now what is standard heat of reaction? Standard heat of reaction. Standard heat of reaction. Actually, if any reaction takes place at standard conditions of temperature and pressure, any reaction takes place at a standard conditions of temperature and pressure, we call that as, and in that chemical reaction, whatever the heat change is there, that we call as standard heat of reaction. Okay, standard means standard conditions of temperature and pressure. At the standard conditions of temperature and pressure, whatever the heat change is there in any chemical reaction, we call that as standard heat of reaction. What is the standard temperature? Generally it is 273 Kelvin or 25 degrees centigrade, and it is pressure is 1 atmospheric pressure. These are the standard conditions. So if any chemical reaction takes place at a standard conditions of temperature and pressure, and at that conditions the amount of heat evolved or absorbed, the heat change is nothing but standard heat of reaction. So here standard heat of reaction, here delta H naught, standard states are represented by the naught. Delta H naught R. Clear? That is standard heat of reaction. Delta H naught represents, that is the chemical reaction takes place at a standard conditions. It is the whatever the heat change is there, we call that as standard heat of reaction. Okay. Now I want to tell you another important point is that here for many elements in the standard state, the elements in their standard state means if the elements here, if the elements are present at the naturally occurring state, for the naturally occurring elements, the standard heat of reaction is considered as 0. Standard heat of reaction is considered as 0 because they are naturally occurring elements. No, for the elements in their naturally occurring state, means in their elemental state which are naturally available, that heat of reaction of H2 is considered as 0. The standard heat of reaction of oxygen is considered as 0. The standard heat of reaction of nitrogen is taken as 0 in their elements in their standard state. The standard heat of reaction of carbon in the form of a graphite, it is equal to 0. Okay, like that. The elements in the standard state, the heat of reaction delta H naught is taken as 0. One of the important point, it will be useful while solving the problems. Okay, clear? What is the heat? Heat of reaction, whatever the heat change in any chemical reaction. If any chemical reaction takes place at standard conditions of temperature and pressure, whatever the heat change is there for that chemical reaction, that we call as standard heat of reaction. Standard state represented with a naught. Okay, now we'll solve one problem. Look at this problem. This was given in JEE 2017. So here he has given 3 equations, and for each equation here you are given with the standard heat of reactions. Now the question is, by using the above data of chemical reactions, calculate heat of reaction, standard heat of reaction of this equation. Now how to solve this one? So here first you have to identify, for solving these problems, first you have to identify what is your required equation. This is your required equation. This is your required equation. Now what you have to do here? You have to get this equation by using these 3. That's it. Okay, so look at this equation here carbon graphite. Here, where is carbon graphite in the above data? Here this side. So here in your equation, this carbon graphite is left hand side. Here also left hand side. Don't change anything. Next, 2H2. So where is your hydrogen? Here is your hydrogen, but here 2H2 is there. Just simply you multiply this equation with the 2. 2H2, 2O2, 2H2O, and 2 into 285.8. Okay, so next CH4 gas. So CH4, this side CH4 is there. Okay, don't change anything. Now what you have to do here, look for the cancellations. So here, by using these 3, I will clear this one, then you will get, I will write this required equation here. Carbon graphite plus 2H2 gas gives rise to CH4 gas. This is your required equation. For this we have to calculate delta H naught R. Okay. Now you have to look for the cancellations now. So here O2, first 1 O2, here 2 by 2 O2, 1 O2. Altogether 2 O2 they get cancelled. 2H2O liquid, 2H2O liquid, they got cancelled. And here 2 CO2 gas, CO2 gas. Now write the remaining. What we have done, simply if you look at, we are getting this equation by using the above data. That's it. So carbon graphite plus 2H2. Anything else this side? No. gives rise to CH4 gas. Yes, that's it. So here, how you got this? How you got this equation? Now, how to find out delta H naught R of this above equation? Here, which is equal to minus 393.5 plus 2 into minus 285.8 plus 890.3 kilojoules. Okay. Solve this question. So I forgot to give in options, no? I'll write options here. Now these are the options given to you. Now solve this one, which is equal to minus 393.5 minus 2 into 285.8. So this will be 571.6. 571.6 plus 890.3. So here this plus the 393.5 11 3 4 5 9.5 965.1 plus 890, which is equal to 961 890 890.3. So this will be 24.8. So here 74.8 minus 74.8. This is your answer. Clear? Clear? We'll solve two more questions. Here first you have to identify the required equation by adding the given equations, or by subtracting the given equation, or by dividing or multiplying with numbers. You have to get the required equation by using these equations. That's it. You will get your answer. Okay. Now the next question is, this is JEE 2023 question. Here these are the two equations, and delta H10 standard heat of reaction is minus x kilojoules per mole, and for the second reaction it is minus y kilojoule per mole, and here delta H R naught for the reaction. So what is our required equation? This is our required equation. You pause your video and try to solve on your own. The same procedure. So here how to get the required equation from these two equations. So what is our required equation? First look at this required equation, carbon graphite. This is your left hand side. So here in the reaction also this is carbon graphite left hand side, no problem. So here it is half O2. So here oxygen also your left hand side, no problem. But here it is CO. Here product side CO is there. But in the given equation it is on your, here in your required equation the CO is on your right hand side. This side CO is there, this side. So here, but in your equation here the data given for this equation, that is minus x kilojoules. Now what you have to do for this type of problems, you just reverse this equation. So here you reverse this one, reverse this equation. So here 2CO2 gives rise to 2CO plus O2 gas. CO gas, CO2 gas. So if you reverse this reaction, this delta H naught 1 will become, sign will change, plus x kilojoule per mole. That's it. Now in your required equation here 2CO is not there, only CO is there. So what you have to do? You have to multiply with 1 by 2. So here if you multiply this equation with 1 by 2, you will get what you will get. So here 1 by 2 O2. So you will get CO2 plus CO. This you will get by multiplying this equation 1 by 2. So what this will become? X will become X by 2. Got this point? 2, 1 by 2, 2, 1 by 2, 1 by 2. Okay. Now here, what is your second equation? C graphite. Write as it is. C graphite plus O2 gas gives rise to CO2 gas. Look for the cancellations here. Here delta H1 not 2. It is equal to minus Y. So look for the cancellations here. CO2, this CO2 and this CO2 will get cancelled. Okay. Now here C graphite, what is our required? Look, check whether we get our equation or not. Plus O2 gas gives rise to CO. Here what you have to do? C plus O2. Here one molecule of oxygen and half molecule of oxygen. 1 minus 1 by 2. So you will get half O2 gas. So how to get this delta H not for this entire reaction? So here it is X by 2 minus Y. So X minus 2Y divided by 2. X minus 2Y divided by 2. This will be your answer. Got it? Same procedure. Okay. Now look at this question. Two reactions are given below. And here for the two reactions delta H naught is given. Standard heat of reaction has given. Now he is asking you to find out the enthalpy change for this reaction. So what is our required equation? This is our required equation. This was asked in 2024. JEE 2024. So here in your required equation, simply first you observe these chemical reactions. In your required equation, here it is 3C is there, which is here 3C is at your left hand side. Here also carbon solid is your left hand side. But here what is the difference between these two? Here in your required equation 3C is there. So you multiply this equation with 3. So what this will become? 3C, 3 by 2 O2, 3C. Okay. Now look for the cancellation and this will become 3 into 110. So which will be equal to minus 330 kilojoules per mole. Okay. Now look for the cancellations. So here what is this one? 3C plus Fe2O3. Here you have to do another one. Here Fe2, you have to reverse this equation. You have to reverse this equation because for required equation Fe2O3 is there this side, but here Fe2O3 is this side. You reverse the first equation. So this will become Fe2O3 solid gives rise to 2Fe plus 3 by 2 O2. So what is the second equation? It is 3C solid plus 3 by 2 O2 gas gives rise to 3CO. Now look for the cancellations. Here this 3 by 2 O2 and this 3 by 2 O2 will get cancelled. That's it. So write down the equation. Fe2O3 solid plus 3C gives rise to here 2Fe plus 3CO. How you get 3CO? How you got this equation? Here by reversing the first equation. So if you reverse this first equation, so here delta H of this resultant, not of this resultant equation is, here you have reversed this equation, no? So plus 822. Here it is minus 330 kilojoules per mole. So this will be 822, 330, 2, 12, 9, 4, 492 kilojoules per mole. Okay. These are here in this video. I have discussed heat of reaction, what is heat of reaction and what is standard heat of reaction. And here I have discussed the 3 previous year questions, JEE questions based on this. So I think this video will be useful to you. Okay, bye.